Good day, guys, and welcome to Intellect Academy. Of course, I am Emmanuel Ofebu, and today we're going to be talking on what? Modulus of Elasticity. So, first of all, what comes to your mind is what is elasticity? The concept is easy. Elasticity is what? The property of a matter that causes a body to return to its original length after the deforming factor has been removed or after it has been deformed. The concept is easy. Of course, we know that there are two types of material. We have the ductile material, and the second we have what? Brittle material. Ductile material talks about a material that undergoes considerable elongation before reaching what is elastic limit. Now, when it reaches this point, it breaks. So the concept is easy. It undergoes what? Considerable elongation or extension before reaching its elastic limit. That's what a ductile material is. But now, a brittle material is a material that undergoes any small or slight or new elongation. Its material would what? Break. So under this, so the modulus of elasticity is what? Is a quantity that measures an object resistance to being deformed elastically. So the concept is easy. The modulus of elasticity measures an object resistance to being deformed elastically. Of course, there are three types of what? Modulus of elasticity. So we have three types. I want to talk about types of what? Of elastic modulus, which is also known as modulus of elasticity. So under the three types, the first we have what? Young's modulus. We have Young's modulus. Now take note. Of course, Young's modulus arises when the stress in the material is directional to what? The strain in that material. So you have modulus denoted by E is equals to what? The stress all over what? The strain. So it's denoted by this symbol. X signifies stress, X signifies strain. Of course, we know that this is F over A over what? Extension over original length. Of course, we have E as what? F L over what? A extension. Second type of modulus of elasticity is called what? The shear modulus. Shear modulus. Shear modulus, also known as modulus of rigidity. Now take note. Now this shear modulus is mostly in relation to what? The couple, torque, and the angle of twist. It's mostly in torsion. So let's donate this by G, and this is mostly in when a material undergoes torsion due to the torque and the couple of that material. Of course, let's say we have a relationship where we have torque and couple relationship with angle of twist relationship. Of course, we know that the torque in that material is a couple multiplied by what? The angle of twist. Of course, we know that this is twist angle, angle of twist, and we know that this is couple, and we know this is what? Torque. Of course, the concept is easy. We donate the shear modulus as G is equal to what? 2CL over what? Pi a raised to the power 4, where C stands for what? The couple, which can be getting by knowing what? The torque and the angle of twist, and we know L stands for what? The length of that twist wire, and we know A stands for the diameter of the wire, where we know pi is a constant which is equal to 3.142, and we know what 2 is. Of course, 2 is a constant. So So the concept is easy. This is shear modulus. Of course, this is relationship. So you can asterisk this formula. Then the next one we're going to talk about volumetric modulus. Volumetric modulus. So the third type of modulus of elasticity is called volumetric. So we have volumetric modulus, also known as bulk modulus. Now take note, this is denoted by B. So we're having a case where B is equal to what? Volumetric stress all over what? Volumetric strain. That's the concept. Volumetric stress over what? Volumetric strain. Now, of course, we know stress is measured in Newton per meter square. But in the case of volumetric stress, in the case of volumetric stress, you should know that stress doesn't not occur in fluids, mostly fluid substance. So we can assign that stress to be pressure because pressure acts on what? Fluids. So therefore, we donate the volumetric stress as what? The P over what? Volumetric strain. Now we know that strain is what? Extension over original length, right? But in the case of the volumetric strain, it will what? It will be given by dv over what? V, which is more of like the change in volume all over the original volume when you're dealing with volumetric strain. So the concept is easy. Now there will be a negative sign assigned here. The implication of that negative sign tells us about what? A decrease in volume resulting in an increase in pressure. So therefore, we can rewrite this as what? B equals to what? Negative the P over what? The V over V. The concept is easy. There's something we call compressibility. Compressibility. So compressibility is denoted by K. Now take note that compressibility is the inverse of what? The volumetric modulus. So therefore, if we change this, which is by inversing this, we have that this is what? The V over V divided by what? The P. So you know that our negative sign will be here. So when we work on this, we have that K is equals to negative of 1 over what? V over what? The P. So this is the concept of what? Volumetric modulus. We state that volumetric stress does not occur in fluids. Of course, pressure occurs in fluids, so therefore we change this to dP. Now, of course, we said that volumetric strain extension does not occur in fluid. So we cannot measure the quantity of a fluid by valence, right? We can't do that. We need to use volume. So that's why you have in change in volume over the what? Original volume. Of course, let's denote this by V naught. So it will be very easy for us. So the concept of this thing is very easy. The negative sign indicates what? A decrease in volume as a result of increase in what? Pressure. So this concept is very easy. Everything about the modulus of elasticity, the Young's modulus, the shear modulus, and what? Volumetric modulus, also known as the bulk modulus. So this concept is very, very easy. In our next class, we're going to be talking about elastic potential energy.